Hey 7th graders, today's lesson is 1.5 and 1.6 natural selection. Your learning targets for today: I can predict how environmental changes can influence the distribution of adaptive and non-adaptive traits in a population. Alright, so moving on, not a ton to add to your notebook today, but go ahead and open your OneNote and add key concept number 5 to your key concepts page. So key concept 5 says whether or not a trait is adaptive depends on the environment. So we really can't decide looking at a trait whether it's going to help an individual survive or if it's going to make it less likely for that individual or that population to survive if we really don't know anything about its environment. All right, so let's move on. Activity 2 is the warm-up. So what you guys see is a little histogram, and you guys have a population that was 50 generations ago. Remember, 50 generations is not necessarily the same as 50 years. If we're talking about generations in human beings, we're probably actually talking about 20 times that much, okay? So whatever 20 times 50 would be. All right, so again, if we're talking about a fruit fly, we might be talking, less than a year. So population 50 generations ago and population today. What we see is poison level, so I'm going to assume we're talking about newts, which if we look at our y-axis, yes, we are talking about the number of rough-skinned newts. And then what we see in our environment is we go from no snakes 50 generations ago to now we have the presence of snakes in our environment. And from that reading a couple lessons ago, you guys learned a little bit about rough-skinned newts and how they have different predators, one of which could potentially be snakes. All right, so in our 50 generations ago histogram, we see that we have low poison levels are our predominant traits, but we have anywhere up to some poisonous. So there's a few poisonous newts in this population. And then population today, you guys see that our population has shifted, whereas now we have the higher distribution of that poison level 10, and we don't even have any that are 1, 2, or 3 poison level. Okay, so with that being said, you guys have some questions to answer. For these first two, you guys will need to use your draw tool. So which description matches the histogram of the population 50 generations ago? So go back, look at this population 50 years ago, and then use your draw tool to circle the correct answer. Most of the newts had low poison level traits. Very few had high poison level traits. Most of the newts had high poison level traits. Very few had low. All of the individuals in a population had high, or none of the individuals in the population had high. So circle which one best fits that histogram. Okay, looking at the population today, that's the second histogram right here. Okay, so if we take a good look at that, we can go answer this question. Most of the newts have low poison level traits, very few have high. Most of the newts have high, very few have low. All of the individuals have high level, or none of the individuals in the population have high level traits. Okay, so once you guys have answered these two, go ahead and say how the rough-skinned newt population has changed. So kind of highlight as many changes as you guys can in your answer there. Okay, moving on to activity 3, simulation. You guys have a little claim to make. So this is where we really focus in on environment. We've talked a little bit about camouflage so far. And you guys at this point in your education know what camouflage is. So what we're going to focus on is if we're looking at body color, which would be a form of camouflage to that environment, especially if we're introducing a predator. We can say, all right, with the australopes, which are the little creatures in our sim, if they have a yellow body color, they're always going to have that as an adaptive trait in a yellow environment. So that yellow body color is an adaptive trait in a yellow environment always. Okay, so you're going to either circle agree or disagree. So do you agree with this claim or do you disagree with it? And then, of course, we are going to go ahead and test that out in the simulation. So here are your instructions for the sim. Here is your simulation. You guys can go ahead, right-click, open that link up, and you guys can go into the simulation. While that loads, I'm going to go back and read through your guys' instructions with you guys. So first and foremost, your goal is to gather evidence to support or refute the claim you guys just read. Yellow color is always an adaptive trait in a yellow environment. Okay, so you guys will be doing both environments, so you guys don't have to worry about this. Press next. So you guys will be comparing both environment A and environment B. Okay, so open this simulation and open the mode camouflage. So we're going to go ahead. Let me log in here really quick. Okay, And we're going to look up in the upper left-hand corner. We have those 3 horizontal bars. And those 3 horizontal bars have all the different modes we need. So as I wait again, you guys are going to be looking at the mode camouflage. Under biotic factors, remember biotic is living things, so other living organisms like carnithons. So make sure that we include carnithons. So if we're looking at camouflage, we probably want to see how that affects the predator-prey relationship. So we're going to make sure we have carnithons included. Under abiotic factors, we're going to change the surface color slider to a yellow level 7. So let's go ahead and see what that looks like, if this is ever going to load for me. And then we're going to press run and observe the australopes with different color traits for 50 generations. And then we're going to look at the histogram to see what's happening there. And then we're going to pause it and analyze and check out those histograms to see how our populations have changed with camouflage or not with camouflage. So let's go ahead. And all right, there we go. All right, so we're in camouflage up here. Load the camouflage mode, yes. Okay, we're going to look at abiotic factors. We're going to take surface color to 7. So notice this 7 number right here. That tells us how yellow our surface is. Okay, and then biotic factors, we're not going to change thorn palms. We're not going to change australopes, but we are going to make sure to include the carnithons. So we have a population of 20 of our predator here. We're going to go ahead and run that. Remember, it's going to be an awfully long time waiting 50 generations if you guys don't speed it up a little bit. And remember, you guys can monitor the histogram change right here so you guys can kind of see what it started out as. As you get closer to 50, right now I'm only about 8 or 9, you're going to go ahead and pause it. You guys, again, will need to pause at 50, and then you guys will hit analyze. And remember that you guys can drag this slider back to see what your original histogram looked like. So originally, even though we have that yellow environment, we have a little bit of blues, some greens, and then some of these greenish yellow, and then a little bit more yellow. Okay, and then again, we can look even in our 10-year population or our 10-generation population, we can look and see how these changed. All right, we have more of this blue one. We don't have any of this blue. We have about the same amount of this kind of bluish green, barely any of this color green, less of this color green, more of this color green, more yellow, and then about the same of this color yellow. So we're seeing some differences already, but we haven't necessarily seen enough to make any conclusions. So again, you'll need to let that run for about 50 generations. Okay, once you guys have done that, you're going to go ahead and answer this question. Which australopes were more likely to survive and become more common in the population? So look at that histogram and tell me which bar of that histogram is the highest. So give me that number and kind of a description of the color. Which australopes were less likely to survive and become less common in the population? So look what happened. You guys might have more than one answer for that. Okay, and then you're going to look back at that claim. Yellow color is always an adaptive trait in a yellow environment. So the evidence I observed, you're either going to circle supports this claim or refutes this claim. Refutes kind of means rejects, so it goes against the claim. Okay, and then finally explain what happened to the population in both environments and why that supports or refutes the claim that yellow color is always an adaptive trait in a yellow environment. So when you guys changed it at the beginning, it was just that normal color, and then you guys changed it to yellow. Okay, next part of the sim, gather evidence to support or refute the claim that yellow is always an adaptive trait in a yellow environment. So again, you're going to run that same sim, except you guys are going to change it to level 7, and you're not going to include carnithons. So you're not going to have a predator in this one. And again, press run, watch it for 50 generations, and then answer the same questions. Okay? Which australopes were more likely to survive and become more common in the population, and which australopes were less likely to survive and become less common in the population. Okay? Is that supported or refuted? And then explain what happened to the population in both environments and why that supports or refutes the claim that yellow color is always an adaptive trait in a yellow environment. Okay, moving on to a modeling tool. We're going to be kind of switching gears. We're not going to be looking at australopes in this little section, but rather water storage molecules. So what we're going to be looking at is, again, using a modeling tool and then testing it out in the sim. So you're going to make a prediction first using the modeling tool. So water storage predictions, you guys are going to predict about high levels of water storage and how that could become more common in a population. So obviously if an organism has high levels of water storage, it's very efficient at storing water. Okay, so how can we make that trait more common in a population? What would we have to do to that environment? Okay, so your goal is to predict how and why higher levels of water storage can become more common in the thorn palm population. So again, we want to create an environment where we've influenced those organisms enough that we start to see more thorn palms that have higher levels of storage, so they become better at storing water. So I want you guys to just think about that for a second. What kind of environment would encourage higher levels of water storage? Okay, so what you're going to do is you're going to add environment labels to both the environment boxes. You're going to analyze the histogram 1 and label that histogram with any labels that apply, and then you're going to predict histogram 2. So here are your environment labels right here. You have low, medium, and high. Obviously, we're going to be looking at the amount of rainfall. So the environment is changing from blank to blank rainfall. You guys are going to need to predict that and write either low, medium, or high in there. And then after 50 generations, that should be your guys' big change that you guys made in your rainfall. So you guys got to think, all right, are we going to keep the rainfall the same? Or are we going to go from like low to low, medium to medium, or high to high? Are you guys going to change it? Are you going to increase it low to high, medium to high? Or are you guys going to decrease the rainfall going from high to medium or high to low? Okay, so you guys need to think about what change would make those plants become better at storing water, have high water storage. Okay, all right, so what you guys are going to do is, again, fill in these 3 blanks right here with the environment labels for precipitation, low, medium, or high. And then if you guys remember the last time we did a modeling, you guys are going to use pluses and minuses to talk about these traits. So if it's a trait that you think is going to make it more likely to survive, you guys would label it with a plus. And if you think it's going to be less likely to survive, you're going to do a little minus over the column. So here are our trait variations. We have different storage, water storage from low to high. 10 is going to be obviously your highest. 1 is going to be your lowest. So you're going to take each of these little bars and give it either a plus or a minus if you guys think it's a trait that's going to make it more likely to survive in your environment or less likely to survive. So again, you guys kind of premised the environment here, okay? And your goal, remember, is to increase the levels of water storage. So at the end of this, you really want most of your population being in this 9-10 range, okay? So again, you guys got to think of what environment is going to do that and what that's going to look like afterwards, okay? So really, again, we're focusing on having a lot more water storage. So what environment is going to cause that to happen? So then you guys are going to draw out your histogram down here and tell me how your histogram is going to look after you've made this environment change. How are those traits going to shift, and how's that distribution going to change for the numbers in that population? Okay, so fill out this chart right here, this histogram, with what you think is going to happen. Again, this is a prediction, so it's okay if you're wrong. All right, moving on, let's test that in this sim. Okay, you guys are going to open up the thorn palm water storage. You're going to go to abiotic factors, and you're going to make your changes to the rainfall level that you predicted in your model. So maybe you guys predicted that the water would change or stay the same. Maybe you guys predicted that it would go from high to low or from low to high, so either increase or decrease. Whatever the case is, you guys are going to make that change in your abiotic factor. Remember, a big change is going to result in big results, so make sure that you guys, if you're lowering the water or you're raising the water, that you guys go all out when you do that. So you max it out or either lower it, whatever the case is. Press run and observe for 50 generations, press analyze, and then you guys are going to want to take a screenshot of that final histogram where it shows you guys your blue bar after 50 generations, and then your little gray diagonal stripe bars are going to be your original histogram. Okay, and then answer the question. So this is where you guys will put your screenshot. Remember, if you're using a Chromebook, hit Control-Shift and then the little key above the 6. Click and drag, capture, and then paste that into this slide. If you guys are using something other than a Chromebook, make sure you guys use your snipping tool to copy and paste. And then answer these 2 questions. What environmental change caused the high levels of water storage molecules? So maybe you guys were wrong in the sim, you were wrong with your model. You don't have to go back and fix it, but make sure you guys do figure out the right answer. So maybe you guys were wrong, maybe it did opposite of what you guys thought it would. Then go back and test what you think is the right answer just to double check that you are correct. Okay? And then, did the distribution of water storage traits change in the way you predicted in your modeling tool? So just address whether you guys were right or wrong with your prediction. Okay? Finally, you guys have a little writing activity to do. This, again, goes back to that same histogram that we looked at earlier in this lesson, where we have the number of newts. We're looking at 50 generations ago versus today, and then we're looking at that poison level, high and low. But now we have snakes in our environment. Okay, so consider these two facts. Since the time when the data was collected 50 generations ago, the distribution of traits in the population has shifted significantly. Now many more individuals have poison level 10, whereas before hardly any had poison level 10. Now most of the population has poison level 10. Since the time the data was collected 50 generations ago, snakes became part of the newt's environment. So that's also a key fact for you guys to think about here when you're answering this next question. So we have three little claims. Claim 1 says individual newts became more poisonous because they wanted to. Okay, basically a newt is sitting there one day on a log and he says, today I'm going to become more poisonous. And so he does. Okay, claim 2, the newt population, so we're looking at not just one individual newt but a whole population, became more poisonous because of something in the environment. Okay, and then revised claim number 2, the newt population became more poisonous because the snakes in the environment caused poison to be an adaptive trait. So we got a little bit more detail in claim 2, the revised claim 2, than we did in just the claim 2. So you guys can kind of differentiate which one of those claims you think is the best. What caused the newts to become more poisonous? Choose one of the three claims above, so let me know which claim you chose. And then explain why. Okay, and you guys can also look to explain why the other ones aren't legitimate, why they aren't correct. Okay, so talk about why you're correct, why your claim is correct, and why the other two are not correct. Once you guys are done with that, you are done with this lesson. Go ahead and do your little wrap up here. If you have any questions, circle yes or no. If you do, type them below, and then 4, 3, 2, 1, how do you think you did? And you guys are all done for the day. I hope you are having a wonderful morning, and I'll talk to you soon. Bye.